and today we are going to do a tutorial to conclude the topic. So the first question that we're going to do on our tutorial is a school of 160 pupils, that's the total number of pupils in a school, 75 pencils, so the three pencils, yes, that's a group that we have identified, pencil, group 0 to 75, let's name each P. So moving on, 87 have 10, so we're going to have a group 10, 10, which is 83, and we are going to name it N. We are going to name it N, and 93 have rulers. So we're going to have group ruler, 93, and we're going to name it R. We're going to name it R. So as I've said that if you need to solve this problem, already have identified their concepts. So the best way you can do and you can visualize this problem is to draw a Venn diagram. So the Venn diagram consists of three circles. Consists of three circles. First circle, second circle, and third circle. So we're going to name this one P, and this one N, and this one R. So we have named our Venn diagram. So let's move on. We have 25, we have both pencils and pens. So 25, we have both pencils and pens. Okay. And 30, we have both pencil and ruler. 30, we have both pencil and ruler. And 47, we have both pens and ruler. Draw a Venn diagram to illustrate this information. But it's also part of the question to draw a Venn diagram. So what we are not given are the number of students with both pencils, pens, and rulers. So we are going to let it be X. We represent it diagrammatically at the center where all the three subsets interlock. So we are going to start with the first one, 25. 25, we have both pencils and pens. So 25 here, this part of the circle is 25. I want you to look at the board very clearly and see what 25 represents on the board. So I'm going to take a red marker here so that I can mark 25 is represented by this area, represented by this area. That is represented by 25. So in order to find the remaining region, we say 25 minus x. That's the remaining region. So we have removed the x. Let's move on. 30, we have both pencils and rulers. 30, we have both pencils and rulers. So this region, pencils and rulers, 30. We remove x, this region. And the remaining region is 47. 47, we remove the x. So before we go on to calculate, we need to calculate the remaining region, this one, remaining region. So what we know, let's look at the board for P. What we know for the set P, if we draw the set P is divided into different regions. The set P, this one, is divided into different regions. So we need to remove this first region. We need to remove this first region, which is represented by A. by 25 minus x. We need to remove this region, which is represented by x, and we also need to remove this region, which is represented by 30 minus x, so that we might remain with the region for p. So let's calculate. So region p is given. We want to remain with this. Let's mark it with red pen. We want to remain with this region alone. So we need to remove those interlocking regions. So we have P. So the entire region of P, which is pencil, is a total of 75. So we say 75 minus 25 minus x. 25 minus x, we put in brackets. Then we subtract minus x. Then we subtract the last one, minus 30 minus x. We put a bracket here. So we solve. We say 75 minus 25 plus x minus x plus 8 minus 30 plus x. So we are going to have 75 minus 25, that's 50. 50 minus 30, that's 20. So we are going to have 20 plus x, because these two x cancel out. So this region is represented by 20 plus x. So you have managed to solve for the first region. I want you to look at the board very carefully and look at what we have done. So let's solve for the next region. We're going to use the same format. Let's solve for the next region. So let's solve for the region N, which represents pen. Region N, which represents pen. So 83 minus this region minus x minus 47 minus x. Then we have this one. We're going to remain with n is equals to 83 minus 25 minus 49 plus x minus x plus x. So we're going to say 49 plus 25, that's going to be 73. 83 minus 73, that's going to be 0, 1. We're going to remain with 10. We added this one and this one to get 73. We're going to remain with 10. N is equal to 10 plus x. So this region is going to be represented by 10 plus x. So let's calculate the representation of that region R, which represents rulers. R, which represents rulers. Total for the region is 93. That is the total for the region. 93 minus that region 30 minus x minus that region x minus 47 minus x. So we can quickly solve 93 minus 30, 93 minus 30 minus 47 minus x plus x minus plus x plus x. So these two x are going to cancel out, right? So we are going to have 30 plus that's going to be 77. So we are going to have 93 minus 77. We added the one that is negative. So 93 minus 77, we're going to have, we borrow 1 here, then we have 3, 6, this one becomes 8, 16. So you're going to have 16 plus x. So we have 16 plus x. So you have managed to illustrate all the information on the main diagram. So that's all the information illustrated on the Venn diagram. So let's move on to part 2. How many pupils have pencils only? How many pupils have pencils only? We want to find how many people have pencils only. So we need to solve for x. We need to solve for x. In order to solve for x, we say that the total 160 is equals to, we add all the individual regions. So this is 20 plus x plus 25 minus x plus x plus 30 minus x plus 47 minus x plus 16 plus x plus 10 plus x. So we have added all the regions that are here. We added all the regions that are here so that we can remain with our x and we can remain with the value of x. So let's group the like terms together. Let's group the like terms together. So we're going to have 20 plus 25 plus 30 plus 47 plus 16 plus 10. So we have grouped, we have managed to group all the non-variables together. So we have 20 plus 30, that's 50, 50 plus 10, that's 60, 60, 60 plus 25, that's 85, plus 47. So 85 plus 47, 12, that's going to be 12, 80, you have 132. So we are going to have 132 is the total of the variables. So we can just remove this one and say 132. Then we look at the x's, positive, negative, positive, negative, they cancel out. So you have a positive, negative, then the remaining is one positive. 132 plus x is equal to 160. Now it is reduced. So you take this one, 132, and it crosses over. When it crosses over, the answer becomes x is equals to 160 minus 132. So you have 160 minus 132. The x is equal to 28. So the x becomes 28. So you have managed to solve for your x is 28. You have managed to solve for your x is 28. But the question is, find pencils only. Pencils only is equals to 20 plus 20, 20 plus x, which is 20 plus 28, which is also 48 students. Those are the number of students with pencils only. Let's move on. Let's move on. It was an interesting question. Very interesting questions. So shared. So this section of questions is going to be a little bit challenging. It's going to be a little bit challenging. But if you follow what I tell you, it's going to be very easy. So you have a set PQR. You have a set PQR. So you draw it diagrammatically. It's P. You draw the P. And you draw the Q. And you draw the R. So you label them PQR, Q, then R. So you are told to shade the region represented by the following. So you shade it as you go. The first thing that you are told to shade the region P union Q. You're told to shade the region P union Q. P union Q is region. You shade region P union Q. That is what you shade. Then you're told that that region that you shaded, you're told to shade the P intersect Q. P intersect Q, this is P intersect Q. And after that, you're told to shade all the region that is outside R. This is R complement. You're told to shade all the region that is outside the union of this intersection and R. All the region that is outside their union. So I will take a red pen and shade region, shade that region. So I'm going to shade it like this. I'm going to shade it like this. I'm going to shade it. Since this is R complement, R complement, you're make sure that you're not going to enter into R here. R complement, R, R complement. So as you can see, that the only region that is shaded twice. This is the only region that is shaded twice. This is the only region that is shaded twice. Hence, that qualifies as your answer. It qualifies as your answer. These ones were just for looking. These ones were just for looking. They're just looking for the answer. They're just looking for the answer. So the region that you're looking for, that you must shade, is this one. This is the region that you are looking for. The region that you must shade. The one that possesses or colors, this one. This is the region. It's very simple. So let's move on to the next one. Let's move on to the next one. So if PQR again, put your P here, put your Q here, put your R here. So you label them. Let's try and label the blue one this time. So your P, Q, R. So you're told to shade all the region. Firstly, P complement, P complement. So everything that is not in P is going to be shaded. Everything that is not in P is going to be shaded. So we shade everything that is not in P. Make sure that when you're shading, do not shade P region. So this is the region that does not involve P. Shaded entire region that doesn't involve P. This region is intersecting. This region is intersecting with the union. This region is intersecting with the union of R, PQ, and R. This region of P complement is intersecting with the union of Q and R. So let's shade the entire region that represents the union of Q and R. The union of Q and R represents this entire region. We can shade it like this. The union of the entire region that represents the union of the entire region that represents the union. You can see that I'm including these two that were not included in P complement. So you see, the entire region that represents union. So you can see that our answer is this region. This is the region that we want. This is the region that we want. The one which is checkered. The one which is checkered.